Hello, I believe my voice is absolutely clear and you can hear me. आज सुबह की क्लास के अंदर हमने एक बहुत इंपॉर्टेंट टॉपिक किया था. आई बिलीव एवरीबडी हैज गॉट द इंफॉर्मेशन अबाउट टुडेज क्लास. और जिसको नहीं मिली है तो हम जरा इंफॉर्मेशन भेज देते हैं. जस्ट आपको बता देता हूं कि आज शाम को 6 बजे फिर से हमारे पास क्लासेस हैं. हमारी फिर से क्लास होने वाली है शाम को 6 बजे. आपकी 5 बजे के एक छोटे से सेशन के बाद वी आर गोइंग टू हैव द क्लास एट 6 PM वंस अगेन. आवाज आ रही है, वॉइस आ रही है? ओके, या आई एम ऑडिबल एंड विजिबल. और सचिन सर अभी बस क्लास खत्म कर रहे हैं, कर दिया उन्होंने क्लास खत्म. नहीं, कौन सी वाली शेयर कर दी? ये वाली शेयर करनी थी और कर मैंने पता नहीं कौन सी दी. Okay, I believe you have been shared. Everybody has been shared. Okay, let's get along with the third law of thermodynamics. And third law of thermodynamics करने से पहले जरा छोटी सी बात, हमारे पास एग्लीलिक्सर का प्रॉपर बैच हमारा शुरू हो रहा है 11,999 with the code WS Live. You can use the code Anoop AV Live also. आपकी मर्जी है, आप कोड यूज कर सकते हो. कौन सा यहाँ पे कोड यूज कर सकते हो? यू कैन यूज द कोड AVLIVE एज वेल. तो आप कोड AV Live यूज कर सकते हो, आप WS Live यूज कर सकते हो. So that's what we have, 25% extra discount के साथ, and this is what we have. ठीक है. And botany is from 6:30 to 7:30 PM. Chemistry is from 7:30 to 9. 9 to 10 is zoology. Very soon physics also is going to start. This is Elixir dropper batch for Neet UG. Clear? 15,999 दे रहा है ये. Offer ends in 66 days. जल्दी जल्दी ज्वाइन कर लीजिए इस बैच को अगर जिसने भी ज्वाइन करना है. एंड वी आर गोइंग टू स्टार्ट विद द सेशन. और यहाँ पे ये फोन नंबर याद कर लीजिए. अगर आपको कोई भी डाउट पूछना है तो ये डाउट यहां पर आप पूछ सकते हो. ठीक है ना? ओके, चलिए. आई एम डूइंग गुड बाय नारुतो ऑरियो. नारुतो फाइन. ठीक है ठीक है ठीक है. ओके ग्रेट एवरीबॉडी. बातें बंद और ये मेरे बारे में है. और चलिए अब हम स्टार्ट करते हैं बिना टाइम वेस्ट किए विद द थर्ड लॉ ऑफ थर्मोडायनेमिक्स. थर्ड लॉ हमने सेकंड लॉ नहीं किया अभी तक. चलो पहले सेकंड लॉ ऑफ थर्मोडायनेमिक्स करते हैं. ओके, मैं बिल्कुल बढ़िया हूं पर्वत. कैसे हो तुम? स्टूडेंट्स आर इंक्रीजिंग. हाँ, थोड़े थोड़े करके स्टूडेंट इंक्रीज कर रहे हैं. होपफुली दे स्टिक टू द सेशन. लोग लगे रहें तो धीरे धीरे डेवलप हो जाएगा. ठीक है ना? चलो. ओह, मैं अंग्रेजी की जगह हिंदी में पढ़ा रहा हूं. कोई बात नहीं कोई बात नहीं. आई विल स्टार्ट विद इट. So now when we talk about the second law of thermodynamics, what is the meaning of the second law of thermodynamics? We have talked about the first law of thermodynamics. We have talked about first law of thermodynamics as the law of conservation of energy, and there we talked about the various enthalpies and how we talk about the various enthalpy changes. We talked about that. Now we are going to do NCRT today in the evening, and before that, let's talk about yes. Today we have special also Ritik at 8 p.m. 8 p.m. we are going to do the questions of thermodynamics. Fine. So don't waste time यार छोटा सा session है हमारा. Nowadays, 1 hour session seems to be a very small session for me. I feel like I have to take the session of at least 2 hours. I don't like 1 hour sessions now. I believe you are also getting accustomed to that 90 minutes minimum session or maybe 120-minute session. So, when we talk about the second law of thermodynamics, there are certain things which can't be explained by the first law of thermodynamics. First law of thermodynamics talks about the conservation of energy. Now, let us say we consider a very, very simple phenomenon. I take, let us say, I take this piece of paper and I tear it. I tear this piece of paper. By all means, this is a physical change because the chemical composition of the paper has not changed. I have made it a physical change. I have spent certain energy in tearing the paper. I have spent certain energy in breaking the bonds. This was an endothermic process because I broke the bonds. Clear? Now, if I place the paper once again with it, this should be an exothermic process, is it not? Wow. Now, this should be an exothermic process, isn't it? And this should take place nicely, no problems. But what we find is that this paper doesn't stick again. Why does it not stick again? Can anybody give me the answer? Tell me. Why does it not stick again? When we break something, it is a physical change. The chemical nature doesn't change. Still, when we try to stick it together, it doesn't stick. Why? Breaking is easy, but attaching is not. Can you give me the answer through first law of thermodynamics? First law of thermodynamics simply says that energy change is taking place. So if this much energy is being provided and if this much energy is being removed, the reaction should reverse. We talked about reversible process, isn't it? Yeah, it is an endothermic process for breaking the bonds. So it should be exothermic process for formation of the bonds. Arman, I perfectly agree it is a physical change, but why does it not revert back? Why does it not revert back? What is the problem here? If I separate it, it should get separated. If I join it, it should get joined. For separation, I require energy, and when we join, it should release energy, but it doesn't. Why doesn't it? Energy flow is unidirectional. Who cares about it? When did I ask it to be bidirectional? I never said that energy flow should be bidirectional. I simply said, okay, fine. I broke the bond, I applied energy. I attach it, the bond should be formed and energy should be released out. Why did I not get it? Now, this answer doesn't come from first law of thermodynamics. It doesn't. Okay. Now, understand one thing more. Let us understand it. I have a container filled with water. I have a container filled with water. I provide it some heat. The water gets heated up. When I provide it energy, the water gets heated up. Now, water gets the energy. Water has energy, extra energy in it. Fine. Does the molecule have some pocket in which it stores the energy? Where does this energy go? How is this energy stored? Can anybody tell me? Thank you, Mayuri. Zequus. Disorder has more probability to happen. Okay, I'm not talking about disorder probability. I'm just asking you what the disorder is. And why do we get a disorder? I'm just asking you that if I provide some energy to this water, then this water gets the energy. How does it get the energy? Where does this energy go? Now, I'm not going to ask you, I'm just telling you. When you provide the energy, the molecules move. Their movement becomes random. Their movement becomes disordered. So I can say energy is stored in disorder. Energy gets stored in disorder. Okay? Am I clear? You keep on providing the energy to the system and it goes into the disorder of the particle. The particles start moving, the particles start disarranging, they randomize, they become disordered, they become disorganized, everything. And that is disorder. Clear? Am I clear? Now, this disorder is relative to how much disorder was initially there. More the disorder a system already has, less disordered it becomes with a certain energy. मतलब ये कि अगर आपके पास 100 रुपए हैं और आपको कोई 10 रुपए देता है तो आपको खुशी होगी. आपके पास 1000 रुपए हैं, इफ यू हैव 1000 रुपीज और आपको कोई 10 रुपए देता है तो उतनी खुशी नहीं होगी. अगर आपके पास 50,000 रुपए हैं और कोई आपको 10 रुपए देता है तो शायद आप वापस दे दोगे, यार तू रख ले, इंसुलेट कर रहा है, इंसल्ट कर रहा है. ओके, सो योर हैप्पीनेस on getting money is somewhat dependent on how much money you already have. More the money you already have, less is your happiness when you get the money. Is this clear? Clear? Now, what is disorder? What is disorder? Disorder, randomness, and the other word of this is entropy. Okay? Any arrangement different from a prescribed arrangement. Any arrangement which is different from a prescribed arrangement is called a disorder. Clear? And the chance of disorder becomes more As we have more number of particles and we have more types of particle, because more is the number of particle and more is the type of particle, more are the possible arrangements. If you have one spherical particle, it is not going to have any disorder. Wherever you put it, whatever way you put it, it will going to be the same way. So it can't be disordered. But the moment you have two particles, you can always change the distance between them. Okay, you may not be able to change the relative position as such, but you will be able to change the distance between them. And this also is disorder. You have three particles, you can even have more disorder. And you have three particles of different kinds, again, the disorder increases. So please remember that disorder increases with the number of particles. The disorder increases with the types of particle. Because of that, disorder is extrinsic quantity. Disorder is extrinsic quantity, amount dependent. Second, pure substance has less disorder than mixture. Okay? Jeetar beta Rahul, how are you? Jack was hold on, beta, hold on. Okay. And as far as water and ice is concerned, water has more disorder, liquid water has more disorder, ice is organized. Ice is crystalline. Okay. Crystalline solid has more order than liquid. Gases are most disordered. Okay. You may even say more disordered means more entropy. Is this clear? Now, whenever we talk about the change in entropy, I just told you that whatever energy you supply to the system, that energy it gets converted into disorder. Energy you supply to the system, energy gets converted into disorder. Okay. Clear? So, when we talk about this disorder, the entropy is represented by S. Entropy is represented by the symbol S. Change in entropy. You may term it as ds for the minuscule, infinitesimally small change in entropy, or you may call it delta S for a finite change in entropy. Now, this delta S is equal to Q by T. Okay, that is Q is the heat supplied to the system reversibly, and T is temperature at which heat is supplied. Okay. Q is the heat supplied to the system reversibly, and temperature is the T is the temperature at which the heat is supplied. And this is the change in entropy, or you may say change in disorder. Any confusions, anybody here? Zakwas, hold on, Jikwas, hold on. So we have just understood what the disorder is. Clear? Okay. Now, many of the people they relate disorder to the state, but disorder is not actually state. Disorder is more as arrangement. No doubts, gases have a very high disorder. Gases have the most disorder. So we cannot compare any liquid or solid with gases. Gases will always have a higher disorder as compared to solids or liquids. Yeah. Now here comes a very, very important case. And what is that important case that we have? Let's talk about Ande ka funda, concepts of egg. Okay. Now when we talk about egg, when we talk about the egg, now egg has a liquid inside. Okay. Egg has a liquid inside. Now what we do is we heat this egg. Heating can be done in any manner. You can heat it with heating water. You can heat it by heating it on a pan. You can heat it anyway. Omelette bana lo, bhurji bana lo, ubal lo, whatever you want, you do it. And you get the egg, and this is solid. You heat it and you get it as a solid. Fine. Now I want to ask you, I have provided heat to the egg for it to become solid. First of all, egg is the only substance which becomes solid on heating. Every substance becomes liquid on heating. Egg becomes solid on heating. Fine. Now, I just told you that delta S is equal to Q by T. Now, in this case, Q is positive. We have provided heat to the system. So, does it mean that the solid egg has more entropy and more disorder as compared to the liquid egg? So, question is, does solid egg have more entropy than raw egg? Option is yes, no. Give me the answer. Which has a higher entropy, solid egg or the raw egg? Ritik, the answer is no or yes. But the formula says otherwise. Our formula says otherwise. Formula says that the solid egg must have a higher entropy because we have provided energy to get for egg to solidify. And then you will say, sir, it's an exception, isn't it? Ananya, to convert raw egg to solid, I have provided it heat. And if I provide heat divided by temperature, it should give me the higher entropy. My formula says that solid egg should have a higher entropy. Is it an exception? What happened? Ritik, the temperature is not increased. I just provide the heat. The temperature is that only. Listen one thing. The formulae don't lie, and we don't have an exception. When we have the liquid, it has 3D proteins. Third, or rather I should tertiary proteins and quaternary proteins. Here we have primary proteins which have lesser order. Here we have primary proteins which have lesser order. Solid egg has a higher entropy than raw egg, no exception. Zequus, that is the question that you are going to be asked. How can you say we don't know? You have to have a faith in the formula. You have to have a faith in what you are studying. Is it clear? So solid egg is more disorganized. And most important, solid egg is amorphous. It is not crystalline. The crystals have a lower entropy than liquids. Amorphous have very similar arrangement to that of liquids. So amorphous is similar to a liquid. Is this clear, Prerna? Is this clear to everybody? Anybody has any kind of confusion? Ask it then. ये हमने नहीं सोचा क्योंकि तुम तो एक्सेप्शन सोचते रहते हो ना इसलिए तुम सोचते नहीं हो. Okay. So that's what we have as entropy. Are we clear what entropy is? Are we clear what disorder is? Now we get on with one more thing. And this is an observation. This is an observation. And observation is you can create disorder, but to destroy disorder, you create even more disorder. Do you agree with this statement? Do you agree with this statement? You can create disorder, but to destroy disorder, you create even more disorder. Something like I tore this piece of paper. This was regular. I tore it. I disturbed it. I created a disorder, but I cannot destroy it. If I try to destroy it, I'll have to remake the entire paper. I'll have to recycle the entire paper. I'll have to consume a lot of energy. And to create a lot of energy, I will have to create even more disorder. I don't know how many waste products I'll be creating, how much dust I'll be creating, and so on. Do you agree that you can create disorder, but you cannot destroy it? If you can create the disorder and you cannot destroy it, it simply means disorder of universe is continuously increasing. Okay. That could be the first statement, that could be second statement, then there could be a third statement, that is any process which actually takes place leads to an overall increase in disorder. And quite obviously, you can replace the word disorder by entropy. Do you agree with these three statements? Now, these three statements are the statements of second law of thermodynamics. These are the three statements of second law of thermodynamics. Third point, critique. We did this particular point and I said that there is no reversible process. All the processes are irreversible. Now this is irreversibility. The irreversibility is because of the increase in entropy, the disorder, which cannot be destroyed. That is why we cannot get back that energy. Okay, so that is what we have as the second law of thermodynamics. So here we are going to see with the NCRT. We'll check it out the NCRT. So we have talked about the measurement of delta U and delta H in today morning class. We talked about delta U and delta H. Okay. And we have talked about this bomb calorimeter. Remember? In the morning class, I told you about the bomb calorimeter. Work pay. Okay. I'll tell you. Tomorrow morning, 10 o'clock, we have the chemical kinetics class. Tomorrow morning, 10 o'clock. Will that be fine? Everybody would be there at 10 o'clock in the morning. Okay. Just read through it. So this is what we have as bomb calorimeter. Anything you want to ask in the bomb calorimeter? And this is the coffee cup calorimeter. Hot coffee in a cup placed in a room cools down, releasing heat to the surrounding. Is this a spontaneous process? Yes, this is a spontaneous process, Anushka. Yes, this is a spontaneous process. Delta is equal to Q upon T. Q is the heat supplied to the system reversibly. We talk about the entire heat we have supplied is gone into the system. It has not gone wasted into the surrounding. Since we are talking about the entropy change of the system, okay, if it is not reversibly, then some heat will be lost to the surrounding. So there will be an additional change in entropy in the surrounding as well. Then we can't give this formula because how much has wasted, we don't know. When does spontaneous process take place in opposite direction? When it becomes spontaneous in the opposite direction. Okay. Have you read through it? Read through it. Anushka, we are going to talk about the spontaneity at the class at 6 p.m. We are going to talk about that thoroughly. Just read through it and anything you want to ask, ask it. Aman Hussain, what happened? Anything you would like to ask? Go through this question, problem 5.6. Read it. Anybody has to ask anything here? I hope you are reading through it. When solid iodine dissolves in water, I2 molecules move randomly. Will entropy of the system increase? Yes, it increases, Anushka. Why is there any problem with that? Obviously, yes, it increases. And solid iodine dissolves in water to a very small extent. Very small extent. 5.14. 5.14, where is it? We have not reached 5.14. Equation 5.14. Equation 5.14, where is it? Equation 5.14. It simply means that you have the enthalpy of formation of the products minus enthalpy of the formation of the reactant. It is final and this is initial. So change is always final minus initial. So where is the problem here? Tirthraj, where is the problem here? Okay, have you read it? We have already done this in today morning class. Anything you want to ask? All clear? Are you reading through it? Nishant Shukla sir spoke too clean. Great. We end this session today here only, and we are going to continue the session today at 6 p.m. 6 p.m. we are going to have the session once again, and we are going to talk about the third law of thermodynamics. We are going to talk about Gibbs free energy, and we are going to initially talk about the reading of NCRT. So we are going to begin with the reading of NCRT, and then we are going to continue with it. And here there are so good offers. You have 25% scheme, and you have iconic mega week, and this is the schedule. We have 10 a.m. chemistry, and that is chemical kinetics that you are having. Okay. Okay. Telegram channel you have to join. Go ahead and join it. And you attend that 5 p.m. class. Sachin sir and Swati ma'am is going to tell you what are the NCRT, old NCRT or new NCRT, which you are supposed to study. Okay. Tomorrow we are going to finish off with chemical kinetics. We have 2 sessions of chemical kinetics tomorrow as well. Join with me, unacademy.com/Anoop Vashishtha. and the Neat Elixir by Unacademy. Bye bye. We are going to meet at 6 p.m. sharp again. Bye bye.